Problem of the day, sum string. Difficulty hard. Given a string S consisting of digits, determine whether it can be classified as a sum string. What is a sum string? Well, a sum string is a string that can be split into two or more non-empty substrings. I think that actually should be three or more non-empty substrings, such that the rightmost substring is equal to the sum of the two substrings immediately before it, interpreted as integers. And this condition must apply recursively to the substrings before it. The rightmost substring and any number in the sum must not contain leading zeros unless the number is exactly 0. Okay. An example might be helpful here. All right, so what they're talking about is, and actually they express it, starting with the rightmost substring, but I don't even see how you would approach it that way, but we'll look at it going forwards. So let's say we split the string like this. We split the string into 1, 2, and then 2, 4. So we have two substrings, 1, 2, and 2, 4. And the sum of those needs to be equal to the next substring, whatever we choose as the next substring. Well, 1, 2 plus 2, 4 is 3, 6. And we could split off a substring of 3, 6. Now, again, this has to continue to apply recursively. So now we have substrings of 2, 4 and 3, 6. If we add those together, we get 60. And that is, that's the only remaining, that's the rest of the string, 60. So that is a sum string. Let's take a look at what else do we have here. The size of S, the input string, is somewhere between 1 and 100. Okay, characters are from 0 to 9. What is this telling us? That the string can be up to 100 digits. That means we've got a problem with, any kind of data type that we might want to use, because it's, an int or a long is not going to handle a 100-digit number, not even close. So we've got to figure out some other way to approach that. There are two other ways to approach that I can think of. One is a simpler way that we're going to try, and if it doesn't work, we'll change it to the harder way. But expected complexities, O of n cubed. All right, now what is that telling us? Well, that's telling us don't waste a lot of time trying to find some super clever linear way of doing this, because there isn't one. In fact, you can almost consider this a brute force method, O of n cubed. It means we can write a nested loop to just split this string into every possible combination of substrings. Every possible combination. Am I saying that the right way? Well, we'll look at the code. It'll make more sense. But yeah, we can just enumerate all of the possibilities with a nested loop, and then we need another n for something. I don't know what I actually am not sure what the other n. The other n may be for the recursive call, because we want to do it recursively. It may be for summing and comparing digits. But anyway, n cubed. So let's see, topic tags. What are the ones that are not obvious here? Well, recursion, yeah, we're going to do recursion. Backtracking, I'm not sure we're really doing, well, I mean, in a way we're doing backtracking. Yeah, in a way. Okay. I mean, we're always moving forward, but it's possible that we could, pursue some path that doesn't work and then throw it out. Okay, let's take a look. Let's take a look at the code here. All right, substring is the main routine. And we've got a nested loop here of len1 and len2, and we're going to loop through all combinations of len1 and len2. Those are the lengths of the first two substrings that we want to deal with. So if len1 equals 1, and we'll use this example here, if len1 is 1, then, and if len1 is 1, I guess we might as well trace through this one time. The first time through the loop, len2 will also equal 1. And then we are going to call check sequence. Check sequence gets the string, it gets the starting index, and it gets the two lengths. So what does check sequence do? Check sequence gets the substring using len1. So the substring in this case would be 1. Part 1 would be 1. Part 2 is going to get the second substring of length 1, which is 2. And then we're going to add those together, 1 and 2. We're going to get 3. We're going to get the length of the expected sum. We're going to check and see if the two lengths plus the length of the sum is greater than the length of the string. If so, we've gone too far and we're going to have to return false. Now, if the expected sum equals, and now we're going to take another substring, and this substring is going to be the substring that starts beyond the first two substrings. So we got len1, len2. That is the start, and the length is wait. I'm sorry. Yeah, it's going to start at len1 plus len2. So that means in this case it's going to start with the second 2, and it's going to go to 1 plus 1 is 2, plus some length is 3. So we're going to get a substring of length 1 there. What does this do? Well, if we have, if they are equal, and actually let's deal with that. Let's deal with that later. This if statement. This is not going to work with the substring of length 1. So, but what it's going to do is take 1 plus 2 and get 3, and then compare it to a substring of length 1. Is that a 3? No, it's a 2. So we failed there. Check sequence. We're going to have to go back, and we're going to have to go to the next len2. Next len2 is 22. 1 plus 22 is 23. Can we get 23 here next? No. Well, without going through this whole thing, I can tell you that the use of the use of 1 as the first substring is not going to work. So we'll loop through all the possible len2s and fail. Now we're back in the outer loop. Len1 goes to 2. All right? Len2 goes back to 1. Can we make this work with a substring of length 2 followed by a substring of length 1? Well, that would be 12 plus 2 is 14. Is it followed by 14? No. So, all right, let's bump len2 to 2. So now we get two substrings. We get 1, 2, and we get 2, 4. And we do the check sequence. All right, let's do that. We go down here, we get the substring. We want a substring starting at the beginning of the string for a length of 2, which is 1, 2. Then we want a substring of length 2 starting after the substring of length 1. So that substring is going to be 2, 4. Add the strings. So 1, 2 plus 2, 4 is 3, 6. The length of that is 2. Have we gone past the end of the string? No. So now we're going to see if the expected sum, which is 3, 6, equals substring starting after len1 and len2. So it's going to start, the substring here is going to start at this 3 for a length of 2. 6, 12 plus 24 equals 36. Yeah, so that works actually. And so now we can drop in here. This actually will tell us, well, what this is going to tell us is start plus the length of the first substring plus the length of the next substring plus the sum of sum len plus the length of the sum. Does that equal the length of the string? If it does, then we're done. There's no more digits, and we return true. That's not true. That's not the case here, actually. So we need to do a recursive call to check sequence. And again, we're going to pass in the string. We're going to pass in start plus len1, which is 2. We're going to pass in len2, which is also 2. And we're going to pass in sum len, which is also 2. When we do that again, check sequence, we're just going to scoot the whole thing down 2 characters. So we're going to pull off the substring of length 2, but starting at index 2, which is this second 2 here. So we'll pull off a 2, 4. Part 2, again, we need a substring of length 2. We're going to get this 3, 6. 24 plus 36 is 60. That's the expected sum. The length of the expected sum is 2. Have we gone past the end of the string? No. Does the expected sum equal the substring that we would get from a substring of length 2 following part 1 and part 2, 2, 4, 3, 6. We're going to take a substring of length 2 following the 3, 6, and we get 60. And in fact, the expected sum does equal that substring. Now we add them all up. 2 plus 2 plus 2 plus 2 is 8. And that does equal the string length. So we're done. That is a sum string. The thing that concerns me here, there's a couple ways of doing addition of arithmetic on very large numbers. In Java, there's the big integer class. So I'm going to try to do it with the big integer class. I'm not positive that's going to work. If it doesn't, the other way of doing it is you can add the strings as strings. Which is, a painstaking approach. But if we have to do it, I guess we could do it. Anything else to say about this? The leading zeros, I don't think that's an issue. I think that'll resolve itself, really. So, yeah, I don't know. Let's run this and see what happens. Failure. All right, for input 5016. We said true is actually false. Okay. We said true. Why would we say it was true? Oh gosh, it's maybe something about the leading zero. Maybe something about the leading zeros here. Let's take a look at this for a second. So if we split off 5 and 0 and add it, that isn't going to work. If we split off 5 and 1, oh gosh, that is a problem. If we split off 5 and 1. Yeah, it is that the leading 0 is going to mess that up. Okay, so you know what? It looks like we're going to have to put in a routine to add add by to add strings. So I'll do that. Hang on, be right back. All right, we are back. Add strings. Yeah, here's the add strings. Here is the add strings method. Now, I'm not going to go into this in detail because it's a necessary evil. It's not, essential to the algorithm. You just have to be able to, you can use your favorite adding strings or adding integers as strings method. And we're going to try it again. Now it's going to work this time because because I already ran it. So now I have 2 correct attempts out of 3. I didn't want to keep stopping and inserting new add strings methods until I found one that works. But this one worked. So that is the sum string. I don't know, to sum it up, because we're looking for an n cubed algorithm, we can loop through all the combinations of len 1 and len 2 for the first 2 the first 2 numbers. All right, so that's it's a nested loop. It's n squared. We can just try them all, and then we try the check sequence, see if it works. If it in check sequence, we're going to extract the substrings. We're going to use the add strings method to add them, and then we're going to compare the resulting sum with the next portion of the string to see if to see if it's a match. Now, if it is a match, we check and see have we reached the end of the string. If it is if it's a match but it's not the end of the string, we call check sequence recursively. And if it what did I just say? If it's a match but it's not the end of the string, yes, we call check sequence recursively. If it's not a match, we go back and into the nested loop and try the next combination. So that's it. Please like the video, subscribe. You will get notification every time I post one of these, which I hope to be every weekday. And I'll see you next time.